In today's video, I'm going to show you step by step how to make this enemy AI. He has a gun, he patrols, and if he sees you, he's going to shoot you. So whilst he can't see you, he just patrols around, he's walking around doing his thing. He's on patrol. As soon as he sees you, he's going to start shooting, and when he loses sight of the player, he's going to stop shooting the player. I'm going to show you step by step how to do it. And if you want to get the full complete project files to either just see the end result with some extra bonus content, or maybe you just want to support the channel, you can do that, link in the description. Other than that, let's get started. Okay, so I've just loaded up a normal third person template. This is in the Unreal Engine 5.6. You don't have to be in the 5.6, you could be in pretty much any version, to be honest, but it would look the same if you were in 5.6. You'd have the same default map. The first thing we're going to do, we're going to go to the content browser. I made this enemy file and I imported this gun. If you want to use the same gun, you can get it on my Patreon, but you do not need that at all to follow along this tutorial. You can go online, get any one you want. You technically don't even need one of these, but if you want to follow along, you can get the same resources. In this enemy folder, we're going to create a blueprint class of type character called BP_enemy. Right, that's going to be the enemy. And with all enemy AI, along with the enemy, you need an AI controller. That is not spelled right. AI controller. It's like the brain behind the enemy. Just call it AIC_enemy. We're going to open that up. We're going to open the BP_enemy up. Go into the details panel. If you don't have that shown up, click on class defaults at the top and just search for AI. We're going to change the auto possess AI to placed in world or spawned, and the controller class to AIC enemy. This means that whether the AI is placed in the world or spawned in the world, you know, with an enemy spawner, or we physically go in and place them like this, it's still going to get possessed by our AI. And we've just chosen which AI controller we want to possess. It's the brain of the enemy. Nice. So now we're going to create the behavior tree, because we're going to use behavior trees for this. Call it BT_enemy. If you're not really sure what these things are, I did make a video explaining what the blackboard is, what the behavior tree is. So if you're watching what I'm doing and you're thinking, what is a behavior tree, go check that video. I'll put a link in the description. Make the blackboard, call it BBD_enemy. We're going to open up the behavior tree, go to the blackboard, we're going to create a key, and we're going to call it, actually first we're going to look for the object key, and we're going to call it target. This is going to be the key that's going to store our player, but I guess the enemy's enemy info. We're going to go to the AI controller, go to the event graph, we're going to get rid of begin play and event tick. Again, we're going to say on possess. Right, because then if the enemy spawned in after begin play, if it's spawned in with a spawner, this event will still happen. But if you just spawn in the enemy only with begin play, then the enemy has to already be spawned into the world before you start the game for that function to fire. We'll cast it to our BP_enemy, just have a nice reference, and we're going to promote this to a variable. Just call it enemy. We're going to have a short delay of 2 seconds. Sorry, 0.2 seconds. Just so that everything's had time to load and we're not trying to call something that isn't there. Because now what we're going to do is we're going to say get actor of class. And we are going to say BP_third person character. We're going to promote this to a variable. And we're just going to call it player. We've got a reference to the player. This is how the enemy knows what player it has. And we're going to say run behavior tree. Nice. Choose a behavior tree we want. That's like the default setup we need to do. That's literally the bare minimum. We're possessing the AI. We're getting a reference, just holding a reference of itself. We're getting our target, setting it player, and we're running the behavior tree. Now, there's nothing in the behavior tree, it's completely empty, but we're going to change that. What we're going to do is we're going to add a default patrol to the enemy. That's the first thing we're going to add. We're going to say, how can the enemy just walk around the map? What we need to do to make that happen is we're going to, first of all, give it a mesh. So we'll go to the BP underscore enemy. Just add the SKM Quinn simple and minus 88 on the location, minus 90 on the rotation, just so it's looking the right way. Compile save. Now we can see them in the world. We will give them an animation class. I made an animation class called BP underscore enemy rifle. This is just the default animations put into a blend space. I'm not going over doing that because I think it's completely irrelevant to the AI we're working on. But if I just show you, I just made a blend space. It's literally just all of the animations that come by default put into a blend space. I haven't imported any animations, it's all the default ones. Again, if you want to just get that on my Patreon, you can do if you don't want to set it up yourself. But it takes 5 minutes. Pretty simple. So add that animation. Now, something that's really important when working with AI is making sure you add a nav mesh bounds volume. I think this is probably the most common mistake that people make, not adding the nav mesh bounds volume. It basically defines the area within which your enemy can perform calculations. So I'm just going to center it to the beginning of the world, 0, 0, 0, 25 on the X, 25 on the Y, and 5 on the Z. That just means it covers everything. As you can see, when I press P on my keyboard, everything's gone green. All the green areas are the areas that are within this nav mesh bounds volume. All these green areas are the areas that the enemy can perform calculations in, that they can go to. So that's very important. We've got the nav mesh bounds volume. So we're going to go to the behavior tree. We're going to click new task. We'll just leave it in this default folder for now. We won't be making too many. Usually you'd make a new folder called tasks to organize, but we won't have too many. So just so we can see everything, make a new task, BTT underscore patrol. Nice. Override, receive, execute AI. We're going to say AI move to. The AI we're moving is the controlled pawn. Where we're moving it to, remember this is just a patrol, so we want them randomly moving around. We can say, we want our enemy to just move like in a location that's near it, right? We want our enemy to just look around, walk around, and just kind of randomly walk around. We could have a specific patrol path. I did set up a patrol path when I did my state tree video, so you can check that out if you want to look at specific patrol paths, but otherwise, you can just have randomly walking around, which is what we'll do. And there's a really nice function for that. Get random reachable point in radius. Now, to do that, we first need to get the actor's location, just like so, calling the function. Then we can say get random reachable point in radius, and within a radius of 1000, just an example, you could put this 2500. Within a radius of 1000 from our enemy, we're going to find a random point and we're just going to move to it. When we move to this point on success, we're going to call finish execute, a very important step, otherwise your behavior tree will never move on. To next task, call success. On fail, we'll call failure, I think, because we'll want to restart. Yeah. So we'll go down here. We'll add a selector because we will choose between multiple states. We'll have patrolling over here in a sequence, and then we'll have attacking over here. So make a sequence, call it patrol, and let's call that task we just made BTT patrol. Don't put underscore. I don't know why, but it just doesn't work. Like if you put BTT underscore, it won't come up. No idea why, because it is the name, but anyways, patrol. That looks good. For now, we will do a state check. So what I'm thinking is we'll have two sequences, and the way we'll decide between them is we will add a decorator. This isn't, you don't have to follow what I'm doing just now. I'm just giving an example. We're going to add a decorator to the patrol sequence, and here we'll basically just check, and we'll check against the enum to see what state are we in, to know if we're patrolling or not. We'll come to that slightly later, but that's how we're going to know whether we're patrolling or not, because on our AI enemy AIC underscore enemy controller, we're going to have a state just in an enum that we keep track of. That is going to dictate, what we're doing. So let's just check. We've received execute AI move to. It's called in the behavior tree. That is called from there in our enemy. We are calling it right. Class defaults. Yes, we are. So now we should see him just moving about. Yep, he's just running around. It's a bit fast, I think, for the patrol. I mean, it doesn't really matter, to be honest, but he does look a little fast. We'll give him a gun as well. We'll go to the enemy, go to the mesh, add a static mesh. Just call this gun. And we will change the mesh to the scar or whatever you import is fine. We're going to go to the mesh. So now we're going to add a socket. This is the way to add guns or swords. You don't just want to try and like move it up and be like, okay, how can I line it up? No. That's not how you do it. You can go to the mesh just by double clicking on it. Find the hand, wherever the hand is, hand underscore R. Go to the hand. We're going to add a socket to the hand, and a socket is just like an extra bone maybe that you've added. Hand socket, and we can add to the socket a preview asset of the scar. Now that hasn't actually added the scar. If we go back to the enemy, like the okay, we've set the mesh there so you can see it, but imagine that wasn't there. Imagine the gun wasn't there. We haven't added the gun to the player's hand. This is just a preview. It's like, what would it look like if we did have something there? But that's helpful because if we go up to preview animation and choose a preview animation A underscore rifle, we can align the rifle with the enemy's hands. I'm not going to be too precious about it. I'll just put it in roughly the right spot because, there's no point wasting your time. But obviously, if you wanted to make it more precise and in the right location, you should definitely spend more time aligning it. But for me, that's fine because I just want to get it done quick. And then we go back to the gun and we can parent the socket to what we just created. IK underscore hand. That is floating in the air. Just take a second, have a guess. Why is that happening? Why do you think that's happening? I'll tell you. It's because on the location, when it was all the way down here, I moved it up a little bit, and that changed this location over here. So we need to just 0 everything. Make sure the location is zeroed, and then it will go exactly to the origin point, which is now the socket, right? So -80 is -80 from the socket position, so that's why. Go back here, you can see he's running around, he's got a gun in his hand. Great. But now he's not just going to run around, right? We want him to see us and we want him to react when he sees us. So that should be shouting out in your head, AI perception. Or maybe you've never heard of AI perception, in which case you should check out my video where I explain all the beginner concepts for AI. But otherwise, it's got AI perception, right? What sense do we want to use? We want to use sense sight. He's going to see us. You could say he's going to hear us. He's going to sense us with damage. All those things. There's a few senses to have, but I just want to have AI perception. If he sees us, he reacts. So we're going to go to AI perception, senses config, hit the plus button. We're going to add AI sight config, go under the index, go to sense, 300 centimeter, 3,500, that's fine. Peripheral vision half angle. So having this 90 degrees basically means that as he's standing here, he will see everything that's in front of him, everything to the side of him, but nothing behind him. It's like from where my camera is here and where the arrow's going, this is like a plane where he's going to see, and it's everything on this side, everything facing the arrow he can see, everything behind he can't. I'm going to change this. I'm going to say 180 degrees. And that means he can see all around him. It's not 360 for all around like you'd expect. It's 180 degrees, means he can see everything in front of him and behind him. So I just want him to be able to do that because I think that's, I just like that, prefer that, but you don't have to do that. You could definitely set that to 90 degrees and see what happens. Detect by affiliation. So we're gonna click on this little drop down. We're gonna say neutral and friendlies. This just means we don't have to like play around with the settings, seeing who's he gonna detect, who's he not. Max age, I'm gonna set it to 5. I like to do that just by default. We're not gonna touch that today, but what that means basically is after he stops seeing us, how long does he remember that there was something there for? You know, you might want to say like he's gonna see you, and if you stop seeing him, or if he stops seeing you for 5 seconds, he's gonna go and investigate. When he finally forgets, then he goes back to patrol. Maybe that's what you could say. And we're gonna go into the events, click on perception updated. When anything happens, when any of the sensors are updated, we want to be notified. Right, we want to be notified. We can just go down here, updated actors. We're probably only going to see one. Oh, that's not what I want to do. Only going to see one, but we always just say a for each loop. Nice. And actually, before we do this, just keep that in the corner of your mind. Before we continue with perception updated, we should set the target we set on the blackboard. Here we set a variable. I'm just going to click F2 to Control-C, copy the name so we can input it later. And we're going to say inside the AIC_enemy, get blackboard. And this automatically gets the one you're using. You don't have to like cast, check if it's the right one. It's always the right one. And we can say set value as object. It has to be object, not actor, because there is no option for it to be actor. But when we get the value later, then we can get it as an actor. So then it'll be fine. Here we will input the player we started as a variable earlier. Keyname, we will make this a variable called target keyname. Compile, save, and set the default value to Control-V, which is just the target. I said Control-V because I copied it from the blackboard over here, but it's just target. This is case sensitive. If you had target with a lowercase t, it wouldn't work, so make sure it's 100% the exact same thing. Now we're going to set up the on perception updated. Okay, so now we are going to set up the perception. The first thing we want to do is we want to get the actor's perception. We can literally just do that by saying get AI perception up here. This is just like dragging it in from here, and we have a function get actor's perception, and this will just tell us everything that we know about the inputted actor. So what we're inputting here, let's just say this is the player, right? We're running around, we run in front of the enemy. He's seen us, like his perception's been updated to contain us as information, and we can get all the information about the actor, which is us, from here. So we've got the info. I'm gonna break this so we can just see everything that's in this struct, and we're gonna do a for each loop on the last sensed stimuli. Then after that, we're gonna say get class stimulus with the array element. Get sense class stimulus, and we're going to check if it's the right one, because there's loads it could be. Well, you'll see here, like, look how, okay, that's not the senses, is it? But we're going to say AI sense, okay, it's not coming up, we'll just say sense site. AI sense site. So we're just checking if what we've seen is, well, have we seen it, right? Because this will get updated whether we've seen something, heard something, been damaged, etc. So now we're checking, is our updated perception site? It always will be, because that's the only perception we've added, but you know, at least now we're checking, and I guess that's just good. And down here we're gonna break this again, because what we need to know, we know that we've seen something. Okay, actually, we don't know that we've seen something. We know that our perceptions change on sight, and that doesn't just mean that we've seen something, it could mean we've lost sight of something. So when you see something, this fires. When you stop seeing something, this also fires. And we know, using this successfully sensed, whether we've seen it or whether we've stopped seeing it. So here, we'll just do a branch. If it's true, we're going to do a print string, just to say player seen. If it's false, we're going to do another print string to say player site lost. Compile, save, and now he's seen us. We get player seen, and he's not printing. Why is he not printing? That is not what we wanted. Okay, let's check. So we get into here. I'd imagine this isn't firing. I'm gonna debug this. I'll come back when I've figured it out. Okay, so I've been just playing around for like 5 minutes, and it's just hit me. I set it to 180 degrees so he can see behind him. That's why it's not working. For you, that's like 2 seconds. For me, it's like 5 minutes. I'll keep that in because I just think it's kind of funny. But yeah, so he's gonna see us, and he still sees us when we're behind him because that's what we said. If you said 90 degrees, that's where you'd have had the difference. If you set that to 90 degrees, then site's lost. If you go here, player site lost. Cool. Yeah. The next thing we're gonna do is we are going to create a state. So we're going to have a variable tracking what state the enemy's in, and in our behavior tree we can use that then to go between patrol and chase. You should do this as well. I'm adding another sequence. I'm just going to call it chase, because later we're going to add a function here, or a task rather. So I'm going to go to content draw, go to your folder, mine's just called enemy. We're gonna create an enum, call it e_enemy states, and we're gonna open it. We're gonna add 2 enumerators. We're gonna call the first one, let's call it patrol and attack. So this is how he's gonna patrol, this is how he's gonna attack. That in itself doesn't do anything. It's kind of like an arbitrary value. We've got to set what that means. So we're going to add a value called state, or a variable called state, in our AIC_enemy. Change it of type e_enemy states. Compile, save. And we're going to make a function. Yes, yeah. We should make a function for this, and then we can reuse it. We're going to make a function called update state. And it's going to take an input of the state we're updating. So just call it input param state of type e_enemy states. I did an extra e there. It's not exactly what we wanted. Now we need not just to update this variable, but we need to get this information to the blackboard as well. So we can and we will set this state here, right? We'll update this state. It's nice to have it locally updated, but the important part is that the behavior tree knows. And the way you send data to and from behavior trees is using keys. So we're going to make a new key of type enum, call it state, and under key type, under enum type, we're going to select our enum, and then it knows what enum we're using. So we'll go back to AIC_enemy. Again, we will say get blackboard, and this time I'm going to say set value as, set value as enum. And we can just input the enum. We'll put it from here. There we can input the state we've just updated. The key name, as always, needs to be exactly the same. So I'll promote this to a variable, call it state key name. Compile, save, so we can input a default value. Then I'm going to copy and paste it, just because you want to be 100% certain it's the right one, because imagine you, I don't know, accidentally put a capital E at the end, or you missed an E rather, and that's going to take ages to figure out. Make sure it's exactly the same. Set the enum value. Now we need to call this function, obviously. So when we see the player, we're going to update the state to patrol. When we don't see the player, when we do see the player, sorry. Wait. I have just muddled that. That first one's attack, this second one's patrol. There we go. We've seen the player, we're attack. We lose the player, we go to patrol. When we first start, I think it would be patrol by default. because that was the first one we put in the enum. I think it will default to patrol, but just to be sure, as soon as we start, I'm going to update it to patrol just to make sure we're in the right state. And now, if we go to the behavior tree, we can go to patrol. We can add the default decorator of blackboard on result. Yeah, that's fine. Abort both. Yeah, yes, we do want to abort because as soon as this changes, we want to move back to the logic. I'll go more into that in just a second. State is equal to patrol. Okay, so what this means, what the abort means, observer abort, is if we are in this chase sequence. So imagine we're down here, right, and we're on this function. Imagine we're doing this function and we keep coming down, we keep going to chase. As soon as our state goes back to patrol, it's going to stop what we're doing and it's going to abort what we're doing. It's going to jump back to this state over here and start running that. And that's exactly what we want, because we're chasing the player. We lose sight, we go to patrol state, and then we switch back over here. So we're going to add a similar, I just press Control D there, a similar blackboard based condition, put it over here, and we're just going to change the patrol to attack. So we go, are we patrolling? Do this. Are we attacking? Do this. Oh, I've put chase. I'll change this to attack just to be consistent. And now we'll add okay, so let's define what does our attack want to do, right? We want to not just start shooting the player, but we want to start patrolling the player. I think that'd be good. We're not just going to shoot the player. We want to find a position around the player and shoot them. So go close to them, not up to them, because we're not a melee attacker, right? We're not going all the way up to them. We're just going to find a spot around them, then shoot them. And I think that is the perfect situation to use an environment query system. Environment query system is a way to query the environment around something. So we can use it to basically check the area around something. Before we go into the EQS, which is short for environment query system, I'm going to make a blueprint class. Let's see if I remember what this is. We're going to make a context, is it? Environment, yes, environment query context blueprint base. So this is going to say context. That's not just context. So context, oh my, player underscore context. Yes. Okay. Player underscore context. And this is like an item that's going to return our player, like the instance of our player, which we're going to input into the environment query system. I'll show you how to use that. We're going to open the context, provide single actor, the query actor. This isn't like the player directly. This is whoever's asking, whoever's like trying to find out, which is going to be the owner of the behavior tree, which is going to be AIC underscore enemy. So we can cast to actually, can we say first we need to say get AI controller, because this isn't a controller in itself. Get AI controller, then we cast to AIC, then we can say get player. Now we pass this to resulting actor, and this is how we can then use our player in our environment query, because we don't just want to like query any environment, we want to query the environment, so the space around the player. So if you go to the environment query off root, so you can choose multiple different types of shapes. You can have a donut, cone, circle. We'll go with the donut. I mean, in theory, you could choose any of these. You could have a grid, but if you want to go in a circle around the player, I think that makes sense. We're going to add a test, which is pathfinding. So that basically just means like, is it possible to go from where the enemy is to the player? You kind of always have to have that. I don't know. I mean, maybe you don't in some cases, but usually you would. Distance to query, we're going to say the minimum of 150. Ooh, Maximum. We're gonna put this to I'm gonna put this to 5,000. Now, what that means is when we generate 8 points, that's what it's default set to, right? 8 points. When we generate the points, we want to go to a point that is more than 150 units from us and less than 5,000. Actually, I'm going to change this to 10,000 because I want it to cover the entire map. Because if we don't fill the entire map with this distance, then if we, are on the opposite side of the map when the enemy sees us, they're not going to be able to get to that point because it's going to be too far away from us. And more than 150 just means he's not going to move from one point to the point next to him. Now I'm thinking about it, you probably could just delete this. You probably could just get rid of this, to be completely honest. Probably, yeah, let's just get rid of it. Boom. Right, get rid of it. The only other thing we need to worry about here is click on the donut, and we're gonna query around the player context. That means we're gonna query these points. We're gonna generate these points around the player, and that's all we need to do. 8 points. That looks good. And in our behavior tree, we can say run EQS query, and then we're going to make another function which is going to take the result of this. So the EQS, we've only got one, EQS underscore strafe. Plug that in. Blackboard key. This blackboard key is where we're storing the result of the EQS, and the result of the EQS is the chosen point. So we said we generate a bunch of points. So we don't just generate a bunch of points, we choose one of them as well. So we generate 8 points, and what it does, it automatically finds the best point for you to use. It scores them all, and then it will find the best one to use. If you want to really go in depth, then let me know in the comments, and I'll do a video where we really talk about EQSs. It's quite an interesting topic actually, so if you want that, just let me know. But basically, you just, out of all the points, you check each point based on conditions. Right now we've only got one condition, which is it possible to go there? And then you return 1 point, which is the best point. So here we've got the single best item. You could choose random from these or all, but here we're saying the single best item. The single best point out of this query is going to be stored in this blackboard key. And to store a point, it just means a location. Right, you're not storing some special weird object. No, you're storing a location, and for that we need to make a new key. We're gonna make it of type vector. We're just gonna say EQ. Well, no, we want to limit to the EQS. We'll say point of interest. That's just a vector that we can use in the behavior tree. So when we run the EQS, we can store the point that it generates in this point of interest, and now we can make another function. We haven't made it yet, but we can make another function that will just make the enemy move to that location. It says make a new task, BTT task blueprint base, call it BTT underscore strafe. Okay, and then execute AI. I'm going to say finish execute, just because we know we're going to need it, and we'll just fill everything in between. AI move to on success, on fail. What do we want to do when we fail? Do we want to succeed or do we want to fail? Let's think about this. Imagine we're running the EQS, we don't get to the point. If we don't get to the point, it might mean we've gone back to patrol, so we will fail, and then it'll automatically reset everything, and then we'll just decide what we're doing again. I think that's logical. If we don't get to the point, something's probably gone wrong. We'll just reset. Sounds good. What are we moving? We're moving the controlled pawn. And what are we moving to? So how are we going to get the information we set? If you watched my AI beginner video, you'll know this 100%. If you haven't, I'm about to tell you. The variables, you're going to add a variable. Well, you just call it whatever you want, right? Let's just call it point. And you're going to make it of type blackboard key selector. instance editable, expose, and spawn. The Blackboard key selector variable type is a variable type that allows you to input any key from the Blackboard. So if we go here, we haven't added the state yet, or task rather, BTT strafe, you can see point, we can access any of the keys. So we can input the point of interest. We've just stored it here. The value, we can input the value into this one. We're taking that position we got from the EQS into this one because we've got it in the Blackboard. Cool. In Strafe, now this is kind of like the reverse steps of when we were in here and we had to say set value as object. Here we're going to say get value as vector. Okay, technically get Blackboard value as vector, that's the function, but it works the same. Plug it into destination, acceptance radius 5, that is cool. No need to worry about that. Okay, so when you move to a location, by default, your enemy is going to face that location, right? And that makes sense, that's logical. But if you're shooting the enemy or shooting the player, the enemy's enemy, you want to constantly hold the focus on the player. So before we call this function, what we're going to do is we're going to make another task, blueprint base. We're going to call it BTT underscore set focus. See execute AI, and the point of this task is just to set the focus to the player. Make sure we're looking at the player, and then we do all of this so that whilst we're moving to this new location, we're going to be looking at the player. So we're not just moving forwards, but we're kind of moving to the side. So in this function, off the controller, not the control point, off the controller, you can simply just call set focus. That exists, not set focal point. Set focal point takes in a vector input. That's not what we want. We want to say set focus, which will take in an actor input. Which is this new focus. This is going to be our attack target. So we're going to make another variable called target of type Blackboard key selector, because the Blackboard key we're going to input is the attack target. That's not the right one. Blackboard key selector, instance editable, expose, and spawn, so we can see it from the behavior tree. Drag it in, get target. We're going to say get value as actor, not object. We put it in as an object because you can't put it in as an actor, you have to do it as an object, but we can get it as an actor, so we will. Set focus to that actor, finish execute as success. Nice. So go back to the behavior tree, make sure target is there. Now there is a problem here, a small problem, and that's what happens if this runs before we have a valid attack target. That is a small problem, really, because we need to know, have we actually got an attack target? If we try and call this before we've got one, I've done it before, it won't work. So we just want to check. We want to do some good programming, right? Error handling, and we want to make another little check before, just to make sure that we do have an attack target. So Blackboard, we'll say Blackboard key target abort both, right? If we want to end here, if we don't have one, we're going to make a new task. This will all make sense when we've done it, right? I'll go through it again afterwards. If you're thinking what we're doing, I'll explain again after we've done it. New task, call it BTT underscore check valid target. That's what we're going to do. Simple task. Finish execute and receive execute AI. We're going to get the own control. Yes, it's stored on the controller. Cast to AIC underscore enemy. We're going to say get player is valid. And no, we do need to cast first. Plug it into there. Now we want off the valid and off not valid to finish execute. But this is quite interesting because the success pin really does matter here, because the way a selector works, if we just look at this, executes children from left to right and will stop executing when one children succeeds. So what that means is if we do this sequence and this succeeds, then we stop the execution of the whole behavior tree and it runs again from root. So if this always succeeds on the left, we'll never get to patrol and attack. And that's what we want if we don't yet have an attack target. We want this to hold up until we have a valid attack target. And the reason we might not have one is because, I don't know, by a couple milliseconds, something just hasn't loaded quite fast enough. This is just, edge case check. But if this succeeds, we'll never get over here. So actually, on task, it might be like the opposite of what you think. But if this is not valid, we want it to succeed. And if this is valid, we want it to fail. Because if we do have a valid attack target, then this fails and then it moves to patrol. If we don't have one, it will succeed, and because we're on a selector, when it succeeds, execution stops, we reset. That's how we're going to block and check that we do have a valid attack target. Check valid attack target. We don't need an input here because inside the task we're casting directly, so that's going to be fine. And let's check it. Let's see what we're doing. So yeah, he's seen us and he's being complete. Okay, he's running around us, but it looks like he's stopping too soon. He's finding a spot and then he's stopping. So what we want is we want him to continuously be running around us. When he shouldn't stand there. He should continuously run around us in circles. So I'm going to pause here, check it out, and then I'll come back when I've figured out the solution. Okay, so I've fixed the problem. The first thing, there's only two things, it's not a long list. On perception updated, I've added a short delay, just 0.2 seconds, because I think that when we start the world, because we're up on this platform, he sees us instantly. So this AI perception is getting fired straight away, but because this has a short delay, we might not have started the behavior tree when we run this. And if we run this, we have an updated state here. We're trying to update the state, but we can't update the state on this blackboard because the blackboard doesn't exist yet because the behavior tree hasn't ran. So this either needs to have like a short delay, or you could make it so that when the game initially starts, your enemy doesn't see you. If your enemy doesn't see you as soon as the game starts, then you don't need that delay. So I'll just place my enemy here, my player there. I can take that out. That's fine. And the second thing I did, so that's why that wasn't working. But also on our EQS, before I'd chosen, not there in the behavior tree, I'd chosen single best item. Now that chose 1 point, and that was choosing the same point over and over again. So when he'd like run up to me and he was just stood right in front of me, it's because he was still running the EQS. He was still finding a point, but it was the same point over and over again, and that's what the problem was. That was weird. That's just like a physics thing. It's because he tried running like past me. He got a point on the other side. I'm gonna slow him down as well. And now another thing we should change is right now he's focusing us, which is cool, but if I like get out of sight and he runs away, he's patrolling now, but he's still looking at us, because when we started patrolling, we never stopped, or we never reset his focus. So in patrol, I'm just going to go to owner controller, clear focus. Now he'll stop staring at us whilst he's patrolling, which is cool. And in our AI_enemy, we can't get a reference to the movement speed on our player. Even though we have our enemy, we can't just say get max walk speed or set max walk speed. We might be able to get it actually, but we can't set it. Look, set max walk, nothing's there. Right, we can't do it. So what I'm going to do is I'm going to create a function on the enemy to handle this, and then we'll call that function itself. So we will make a function, call it set walk speed, It will take an input of a float for what speed we want. So input param call speed of type float. Cool. And off here, we're just going to get the character movement, say set max walk speed, and we're going to set it to whatever we input. I'm also going to change the default because he is running a little fast. I'm going to put this to 300. I think 300 for when he's attacking, 150 for when he's patrolling. 150 is like a walk, 300 is like a bit of a jog, but he's not supposed to sprint, right? He's a ranged attack person. So if we get the enemy now, and if we say set walk speed, this was when he starts attacking, so now we'll set it to 300, and we can just highlight that, Control D to duplicate, and then 150 in here. So now we should see a reduction in his speed. Yep, going pretty slow. Sees us, now he's running quicker. He gets to us, he's strafing around us, he's running around in points. He's seeing us, he's finding a point that's around us, based off the EQS we defined. He's going to it. The only thing he doesn't do is shoot us. That's the only functionality we've left to add. Now, how do we want to have him shoot us? There's a few ways to do it, I think. I'm going to do it with a line trace. Again, if you want me to really go in depth about why a line trace, what's the difference between line trace versus projectiles, how do you properly set up like FPS shooting, let me know in the comments and I can do a video on that. But the point of today's video was to focus on AI. How can we set up the behavior tree? That was the point of today's video, so that's why I'm not going to go too in depth about it. It's already getting pretty long. Anyways, so we've already given the enemy a gun, but what I think I noticed was if we run into the enemy, yeah, so his gun is colliding with us, and I think that might actually be what caused that little physics problem before when I went flying. We're not supposed to be able to like run into his gun like that, because not only is it colliding with us, it's actually colliding with him as well. Now fortunately it didn't cause any problems there, but if we had a gun in our hand and we had the gun's physics to collision, what would happen is you try and press W to run forwards, and you wouldn't be able to run forwards. Like the gun would be pushing you backwards because you'd be colliding with the gun, and the enemy's sort of doing that as well, which is a bit of a problem. So if we go to the gun, we just search for collision, and I'm just going to say no collision. We don't want collision. We don't want overlaps, generate step up events. This we could uncheck. I mean, we're not going to use it, so we don't need to. Close that. Now we know we have a reference to the player. We know at all times where the player is. So what we're going to do is we are going to set up a system where whilst we're in attack state, we're going to be constantly firing ray traces to the player's location. To do that, I'm going to use a timer. I'm going to have two events. I'm going to have a start fire and end fire. We start fire, that's going to start a timer where every so often we're going to fire this ray trace. You stop the timer, you're going to stop the ray trace. That's how we're going to do, and we can start these functions or stop these functions off of here. And that fits in very nicely. So we're going to make a custom event over in a bit of space, call it start firing. I'm going to say set timer by event, and we're going to promote this timer handle, that's what it's called, it's a timer handle, to a variable, just call it fire timer handle. A timer handle is like a reference to the timer itself. Through the timer handle you can essentially edit the timer or like do things to it, and that's how you can stop it. So we're going to set the timer to looping and to 0.1. If you don't set it to looping, it will do it once after 0.1 seconds, then it will just stop. We don't want that. We want it to loop. Now the function we want exactly, we're going to make a custom event. We're going to call it fire, and we're going to plug this little output delegate into there. It's not the execution pin, it's this little red box. We will come back to this and set up the logic, but for now I'm just going to add the custom event for stop firing, custom event, call it stop firing, and then we can get the timer handle. We can say clear and invalidate timer by handle. Nice. So that's going to stop whatever we start setting on the timer over here. Now, what exactly we want to do a line trace by channel. So just search that line trace by channel to the player. From the enemy to the player. From the enemy, what does from the enemy mean? I'll say from the gun. We have a reference to the gun, so it's just if we get the gun, scroll to the bottom for the actual reference, and then we can say get, is it world location? Yes, get world location. Sometimes it's like actor location, sometimes it's world location. It depends what type of object it is. Anyways, get world location, that's where we're going to start. End, we are going to get the player. Get world, okay, this time it's actor location. Get actor location. It is like simple, it's because it's an actor. I just stop thinking there. Actors to ignore, we're going to make this array, we're going to say self. This is just so it doesn't collide with us. It probably wouldn't anyways, because we're setting it in front of the actual enemy. It's starting from the gun, but you know, just to be safe, we'll start it here. Now if we ran this, I don't think this would actually work. I don't think we'd actually get a valid hit because of this trace channel. If we go to well, first of all, I'll close some of these tabs. We've got way too many open. There we go. If I just Control P to open this up, by the way, and then search for BP underscore third person character. If you go to their mesh, collision, they have ignore visibility channel, which means if we try and trace them on the visibility channel, they're going to ignore it. So we're going to change the trace channel to camera so it hits them, and then we can do a branch. We'll know if it's hit us because if we show it for frame, we'll see it like a green line behind us. We know we'll need to put it on for duration for that to happen. So we'll know if it's hit us or not. And then we'll go over to where we've seen the player on the perception. After here, we will say start firing. And down here we will say stop firing. Compile, save that. Now this means if we're in the attack state, we start firing. If we're not, we stop firing. Let's see what happens. He's seen us, he's shooting us, he's running up to us. All these traces, this means he's found us, he's seen us, he's shot us. He's constantly shooting us as he's walking and running around. His animation looks a bit goofy, but that's literally just the animation. It's because he's not like sidestepping, but that's just the animation. There's nothing we can do about that in terms of logic. And we're getting shot constantly over and over again. And that's it. That is the project. If you want updated and extra features in the project, you can get it on my Patreon. I'll show you just a second what I've added. Okay, so this is the end result. I've added some health bars to the player, to the enemy. I've added a sound when he shoots. I've added a muzzle flash so you can see he starts shooting. I've given the player a gun as well. The player can shoot. All these line traces where the player's shooting. And also, just to make a little bit of a game out of it, if you run into the blue orb, you gain some health, right? It increases your health. So yeah, if you want to get these extra features as well as the rest of the project, get on my Patreon. It comes with all the assets, all the features, as you can see. The core features are the same, but if you wanted to, for example, in the third person, yeah, we got a death screen as well, so if you die, quick restart, just a little bit extra stuff. And it's a good way to support these videos because obviously they're free. Yeah, other than that, thank you for watching. If you got any ideas or things you want to see in future videos, just let me know in the comments.